Complex numbers. What the heck are complex numbers? Well, in this video lecture, the objective is to interpret, to come to an understanding about complex numbers. Okay, so let's talk again about what we know. We know real numbers. Okay, maybe you've heard of complex numbers, but you certainly are familiar with real numbers. Real numbers are the set of all rational numbers, rational meaning any number that can be written as a fraction, and irrational numbers, all those other numbers that cannot be written as a fraction. Pretty much nearly any number you can think of is a real number. These are all the numbers that we think of in the world. Okay, examples. I wrote down a variety of examples. 0 is a real number, a negative is a real number, a positive is a real number, a decimal is a real number, a negative decimal is a real number, a fraction is a real number, pi, the letter E, those are real numbers, and the square root of prime numbers, square root of 11, square root of 2, square root of 3, all of those are real numbers. Okay, so any number you can think of is pretty much as a real number. However, before we talk about complex numbers, let's talk about imaginary numbers. Okay, and here's what happened. Okay, what happens when I have a negative under a radical? We know in the real number system there's no such thing. The square root of -9, for example. Well, I can't do that. There's no such thing in the real number system as the square root of a negative. So an imaginary number is any number that when squared gives a negative result. Take an imaginary number, square it, and out comes a negative. Okay, that doesn't happen in the real numbers, so it becomes an imaginary idea. Okay, so I've kind of written down a little bit of a sentence here. Squaring and getting a negative result doesn't work in the real number system. So we're going to imagine that there is such a number, and I kind of put it in parentheses because we're going to use the letter I. Okay, there is such a number. We're going to call it I for imaginary that could do this. Okay, so we're going to imagine if I took I and I squared it. In other words, I multiplied it by itself. I get -1. I get a negative. Again, that's not possible in the real number system. We're gonna pretend it's possible in imaginary number system. Well, I times I is the same as I squared is -1. Okay, and that's a key thing to remember. I squared is -1 is something we're gonna use. If I square root both sides, the value of I is equal to the square root of -1, and we're going to make use of that as well. And again, no such thing as a square root of a negative in the real number system, but there is in the imaginary number system, and that's why it was developed. Okay, so by accepting that this letter I exists, that this imaginary number exists, we can now solve things that need the square root of a negative number. We can do stuff. We don't have to just stop and say, no solution. We can continue to work and continue to do mathematics with it. All right, so let's take a look here. And I'll also pull your calculator out and show you where this comes up, but I'll start there. On your calculator, so here's the TI-84. If you look here, at the decimal key above it, you'll see the letter I, a small I. It's a blue key, so to access the I, you need to press the second blue key, and then you'll press the decimal button, and you'll have an I pop up on your screen. I'll do that for you right here. Okay, let's clear this out. I'll go to second, and then I'll press that decimal, and there's the letter I right there. I'll just press enter and you can see the I, and that's an imaginary unit, imaginary number. Okay, and again, I is equal to the square root of -1. Okay, so let's take a look at how this comes into play. Example 1. What is the square root of negative 9? Okay, well, in the real number system, there's no such thing. We would say does not exist. But in the imaginary number system, we're going to use the fact that I is equal to the square root of negative 1, and so it does exist. So the square root of negative 9 is equal to the square root of 9 times negative 1. Okay, I just took negative 9 and wrote it as a product. Well, that's the same thing we know from our square root rules. The square root of a product is equal to the product of the square roots. So this is the square root of 9 times the square root of negative 1. Okay, well, the square root of 9 we know is 3. Okay, the positive square root of 9 is 3, and we just stated that the square root of negative 1 is I. So this is going to be 3 times I, which we write as 3I. Okay? So now we can take square roots of negatives. Now let's look at the calculator with this. Okay, one of the things you're going to want to do, your calculator, your TI-84 has a setting. If I were to go into let me make sure, let's see, it has a setting, let's make sure we got it correct. Let's do the square root. So second, I'll press the square root, second square root, and I'm going to put in negative 9, okay, and I'm going to press enter. Okay, mine said, oh, non-real answer. I get an error. My calculator is currently in the real number mode, so I'm only going to get numbers that come out that are real numbers. So if I go to mode, whoops, I got to first go to quit. If I go to the mode key, which is right here, and as I look down, I'll see right down here where it says real under sequential. I'll scroll down to show it to you. I'm in the real number mode. You'll look right to the right, A plus BI. Well, that's the imaginary mode, which we're not quite to yet, but that's the mode. I'm going to press enter and come into the imaginary mode. And I'm going to go back, so I'll quit out of that, and I'm going to try it again. I'm going to do the square root of negative 9. I want it to be able to have imaginary answers, and out comes 3I. So we just checked our work using our calculator. Okay, so let's take a look at another way this is useful. Now we can solve some of these quadratics. So here's one. Solve 4x squared plus 1 equals 0. Well, we know in the real number system, there's no way this is possible. There's no way that you take any value of x, you square it, and that's a positive. You multiply it by a positive 4, that's always a positive, and then you add a 1 to it. You're guaranteed to get a positive in the real number system. But there is an answer to this in the imaginary number system. So I'm going to subtract 1 from both sides, so I can use my square root method. I have 4x squared equals negative 1. I'll divide both sides by 4. I have x squared, there's my 1, is equal to negative 1/4. I'll square root both sides, and I have x equals, don't forget, plus or minus, don't forget you have two possibilities, the square root of negative 1/4. Okay, well, we can solve this using the imaginary numbers. Okay, so let's see here. This equals, okay, I'm gonna divide up like I did before, like I did up here. I'm gonna rewrite the negative 1/4 as a product of positive 1/4 and negative 1. So this is the square root of 1/4 times negative 1. If I have the square root of a product, it's equal to the product of the square roots. So this is equal to positive or negative square root of 1/4 times square root of negative 1. Okay, so I just split it apart. The square root of a product is equal to the product of the square roots. So this is positive or negative Okay, so this is the square root of a quarter is a half, and the square root of -1 we know is I. So the answer is a half I, or positive or negative a half I. I have two answers to this quadratic. Positive or negative 1/2 of an I. Okay, let's check that. We can always check our answers. So let's check. I'm going to do my check. My space is a bit different here. I'm going to do my check off to the right. So let's first check. Let's check x equal to positive 1/2 of an I. So here's my original equation. I'm going to say, okay, so 4 times positive 1/2 of an I plus 1, does that equal 0? I have no idea. Well, I think I'm correct, but I want to make sure I'm correct here. Let's take my calculator out. Okay, so 4 times 1/2, I'll put it in as 0.5. A little easier to do it that way. Times I, remember my I key is the decimal key, that's the second function. So there's my I. I'll close that up. Well, I got to square it, I forgot. Just let's make sure. Oh yes, I got to square it. I forgot to square it here. So 4 times the x squared, I forgot my squared. You probably caught that, didn't you? I'll square this, and then I'm going to add 1, and I'll press enter. Hey, I got 0. That worked. So I feel good that 1/2 I is an answer. It's a solution to this quadratic. Now let's check negative 1/2 of an I. So 4 times, again, replace the x with parentheses, negative 1/2 of an I. Don't forget to square it this time. That's on me. Plus 1, is that equal to 0? Okay, back to the calculator. 4, open parentheses, negative, and I'll use 0.5 again. Now I'll pull up my I key, which is the second function, the decimal at the bottom. There's my -5, negative 1/2 I. I'll close that, square it. I'll add 1, and lo and behold, I get 0 again. So I've just checked, whoops, it looks like I've checked. Well, I should say 0 equals 0. There you go. I just checked it. Okay? So that worked out great. All right, but you can see how we're able now to solve a variety of quadratics, because now we can solve the ones in which we might have a negative under the radical answer. Okay, examples of imaginary numbers. I, of course, 12.42 times I, negative 1/2 times I, which is the same as negative I over 2. The opposite of I, or negative I, obviously it just means you have something in front of an I. There's a 1 in front of this one, there's a 1 in front of this one, there's that negative 1/2 in front of that one. Those are all imaginary numbers. You may be curious as to where do these things have uses. Spectrum analyzing, which has to do with kind of like analyzing voice volume or tone. A lot of uses in electricity, signal processing, your wireless stuff, cell towers, etc., radar. Pretty much, if sine and cosine, if waves are involved. Remember, sine and cosine are your waves. If waves are involved, imaginary numbers most likely are too. Okay, now let's get ourselves to what complex numbers are. Okay, so we've done real numbers, we've done imaginary numbers, so now let's get to what we're looking for, which is what are complex numbers. A complex number is a combination of a real number and an imaginary number. So for example, 7 plus 3i. 7's the real part, 3i's the imaginary part. Okay, in general terms, we would say that we would say a plus bi. Okay, that would be our generalization. Again, a is the real part. I'm going to split this a bit. B is the imaginary part, and I is the imaginary unit. So this is the imaginary piece, of which b is the imaginary part and I is the imaginary unit. Okay, so that's what a complex number is, pulling together the real and the imaginary. Examples, okay, 1 plus I. And of course, this would be 1 plus 1I. We don't need to write the 1, we assume it's there. 39 plus 3I is a complex number. 0.8 minus 2.2I. Okay, there's your real part, there's your imaginary part, and there's your imaginary unit. Negative 2 plus pi times I. The square root of 2 minus 1/2 of an I. These are all examples of complex numbers. Okay? Now, in a complex number, either part can be 0. So you'll notice in these examples, neither the real part or the imaginary part is 0. Real part 1, imaginary part 1. Real part 39, imaginary part 3. Real part 8/10, imaginary part negative 2.2, etc., etc. So neither the real part or the imaginary part is 0, but it can be. Okay, so I made a table to show you some examples of how that works. Okay, so let's take a complex number. How about, because all numbers are complex numbers, how about 3 plus 2I? Okay, 3 plus 2I. Well, the real part's positive 3. The imaginary part is 2. Okay, so that one's straightforward. We saw it up here often. How about the number 5? Well, the real part is 5. The imaginary part is 0. So I could rewrite this. I'll tell you what, I'll erase this and I'll put it as 5. I could rewrite this as 5 plus 0 times I. Okay, so 5 is also a complex number. 5 plus 0 times I. This is where you have, we call this a purely real number, because there's no imaginary part. So it's a purely real number, but it can be written as a complex number. How about negative 6 times I? Well, the real part is 0. There is no real part. I could rewrite this as 0 minus 6I. Okay, the imaginary part is right here. It's negative 6. Okay, so here we have an example. We have no real part. We have an imaginary part. So here's an example of a purely imaginary number. So every number is a complex number. All real numbers and all imaginary numbers are also complex numbers. Everything is a complex number. If the imaginary part is 0, they're all real numbers. If the real number part is 0, they're all imaginary numbers. And in all cases, whether 0 or not, they're all complex numbers. So we got you. We've gone now from what you all the numbers you know about, the real numbers. We added an imaginary, and we just added in complex.